topic is about the quantum mechanics. Quantum mechanics. And so to understand the quantum mechanics, what is the quantum mechanics? So what is the quantum mechanics? I have already explained. If we admitted that if accepting your ignorancy is the name of the quantum mechanics. Some people state that quantum mechanics mean quantization, mean discrete. But this concept is totally wrong. Why this is? Because discrete means countable things, numbers. The number of students are a classical. अगर मैं कहूँ आप लोग बैठे हो, आप classical हो, quantum हो. You are classical. Even discrete things are also classical. So this concept is absolutely wrong if you state that the discrete things is a classical mechanics, quantum mechanics. Because it starts from the quantization of energy. That's why people was thinking that is the quantization is a. But quantization doesn't mean the discrete. There are some things are momentum. If there are many things in quantum mechanics are continuous, there are many things which are discrete. So this concept is totally wrong. Quantum mechanics deal with only the discrete. Even continuous things, there are many spaces when we deal with the continuous momentum space. Okay, so discrete is not important. Okay. So what is the difference between quantum mechanics and classical? So what firstly answer, quantum mechanics means accepting our limitation of observation. Quantum mechanics means there is some limitation on our observation. If in our knowledge, observation or knowledge. If we admit that our knowledge is limited and our ability is limited, okay, our ability. I think observation and ability to observe. If we think that if our knowledge are if we admitted that there is some limitation on observing and then that will be gone. What is the difference between the classical and so next question is what is difference in QM and CM? In classical mechanics, all observable, all physical quantities are representing by physical observable. But in quantum mechanics, so what is the main difference? These are the short questions that maybe come in exams. Okay, what is the main difference? In CM, all observable, all physical quantities may be, not maybe, or observable. Like V is dr over dt, or A is dEv over dt, second derivative, of or first derivative of velocity, or psi is equal to psi m sine omega t plus phi wave function. Okay, I have write it in the form of the text notation. Why I am writing it, I explain it later. Okay, but classically this is this, and this is actually the what are the different parameters here. The psi m is the amplitude, the maximum mean. If you put the t equal to 0 initial state, then it will give you the maximum height. Okay, so this will be the amplitude. Okay, this will be angular velocity. This is time. This is initial phase. What is the initial phase? I think you must be familiar with. Yes, what is the initial phase? So starting point. Okay, for starting angle. For example, if the wave is from starting 0, initial value is 0, then initial phase will be a 0. If wave is starting from 1 maximum amplitude, then if that is sine is maximum at pi by 2, then initial phase will be a pi. Yes, yeah, I must mention, or it is clear. Okay, phi 0, phi 0. Starting from 0 amplitude, phi by 2 starting from maximum amplitude. Okay. So this is maximum amplitude. Sorry, amplitude is also a maximum. Okay, mean that will be wave start from the 90 angle. Okay, I think I don't need to draw the wave. Yes, that is clear. Yes. So everything is, if you know initial phase and omega, you may measure the t. If you know the angular displacement, then you may measure the theta omega. You may find the angular velocity. Similarly, you may find everything related to time period. In classical, you may find everything if you know the initial stage and some initial variables. If you are familiar with that, then you will put the values in that formulas and you will get the result. Okay, but in quantum mechanics, it's totally different. In quantum mechanics, nothing is observable. All 5 postulates of the quantum mechanics is based on only one thing. If you summarize all the postulates, which will be discussed later, if we summarize all the postulates, it means the only one principle, that is nothing can be measured. Only find the expectations value. You can find expectation is most probable average value. Okay. So if may I erase it? So, what is the quantum? So, in quantum mechanics means deal with the motion. You must know maybe some maybe ask the question, what is the meaning of the motion? Oh, sorry, mechanics. Mechanics means we discuss about our study about the things related to the motion. There are 2 types of the mechanics. One is defined as the kinematics, one is the dynamics. Okay, so I think you are familiar with all such kind of words, and you must be familiar because these are the. I know that is some students, usually students think that these are the ignorable things, but I think that I think it feels very embarrassing if someone asks what is the meaning of the quantum mechanics, what is the classical name. But even you know everything about the quantum mechanics, but if you don't know the basic things, then I think that is very embarrassing. Embarrassing. Okay, so I think you should avoid so that you can't feel embarrassed. Okay, so what is the quantum mechanics? I have already explained. What is the quantum? Quantum means nothing is observable, but we may find only expectation value. What is the expectation value? Yes. Expectation value is most probable average value, okay, which is most probable average value may find by defining Hermitian operators corresponding to classical observable. Okay, I think this statement is a complete statement, and that will be explained everything about the five postulates regarding quantum mechanics. Okay, and that will be discussed one by one separately next upcoming lectures. Okay, how we may understand what is the meaning of. I know that this example is not digestive example, but mostly people explain it in this example. This is like that is like if you have n assembles, for example, if you have, for example, experimentally, because mostly students here related to the experimental physics, okay. So if you have jar of equal size, equal areas, have equal, and this is filled with the liquid of equal quantity. There are n jars, like you may solvents, like maybe water, that may be alcohol, whatever. These jars are filled with the equal quantities of the some solvent. Okay, and if you drop ink in each, some inks in each jar. Okay, if you may drop some drops of the equal drops of the some other liquid or ink, then after passage of the time, equal passage of the time, the ink will be distributed equally and homogeneously in each jar. You may measure that time. Okay, you may expect कितने टाइम के बाद ये एक जैसा ही उतने ही टाइम पे सबके में डिस्ट्रीब्यूट, जब टेम्परेचर, if the temperature is same, if quantity is same, if the jar area is same, volume is same, then you may calculate the or observe the at what time these will be at equilibrium position. Okay, yes. But you can never, but now you may say, but not this is, I have already explained, I already accepted it. This is not a very good example, but for understanding, it is little bit acceptable. But you can't guess okay, what is the location of first drop is will not say that maybe here that is different, here may be a different, here may be a different. So you can't guess what will be the position of first drop, second drop, or third drop, or five drop. So that is the example of the quantum mechanics. Means you may guess something, but you can't find the example. You may find the probability, but you can't find the exact position or location of the particle. Okay. Why the quantum mechanics comes? Why this is important, and why we are studying the quantum mechanics, and what are the basic postulates? We will discuss it. The first. Foundation, what is the foundation of the quantum mechanics? Yes, what is the foundation of quantum mechanics? Quantum mechanics is based on the from photons. We know that. Please be silent. Our photons are light. There was a two school of thought. One is explaining it, or one school of thought taking it as a wave, and one school of thought is taking it as a particle. And classically, it has been proved. So classically, not quantum mechanically. Okay. Particle behavior. What was the particle behavior? Compton effect. Photoelectric effect. And it is well explained by the classical. Einstein explained the photoelectric effect and get the Nobel Prize to explain the photoelectric. Similarly, Compton effect is also successfully explained as a particle behavior. But unfortunately, there was other thing that is the wave behavior, like interference, diffraction, and polarization. Interference, you know that the superposition principle of wave interference is explained by the superposition principle of the wave, and diffraction means there may be a constructive interference and destructive interference. Okay, so diffraction, bending of light from the corner or edges, and the third is the polarization. Okay, and all these are properties of the wave. If we consider that regarding momentum, if something is a particle and has a mass, then it have ability to transfer the momentum. Okay, so all these things was explained classically as a particle behavior, and these explained by the quantum mechanical, and classically as a wave. But problem is that these are two contrast things. Something may be a wave or a particle, but not between in these two things. या तो कोई चीज वेव हो सकती है या पार्टिकल हो सकती है. आप कभी ये नहीं कह सकते कि something has a mass and it has not mass. If I say that you are present in class, then it means you are present in a class. I can't say yes. It may be possible कि मेरी याददाश्त कमजोर है. My memory is very weak, and I may say I am not remembered. Maybe you are in class. It is possible, but actually there is only one possibility. You are in class or you are not in class. But in the case of the light and quantum size particle, like if you state the if if you are interested to study the electron, even electron, proton, or they have a behavior as a wave because they also follow these interference diffraction polarization uh, phenomena that have a in electron, and they have a the particle behavior too. So theorists think that at quantum level, when the size become a very small, then it is become impossible to distinguish that are a particle or a wave. So this question is ridiculous, that are foolish, based on the foolishness. If we say that that is a particle or wave. Yes, if something is observable, like your students are here, you know that you have, I know that you have a mass, so I have a belief you are a particle. But if you become very small at any, then I can't define that you are mass or big. Okay, so that's now question is how it is possible. People start working on that. No, how it is possible? Yes, but to understand, before understanding how it is possible, as I have already explained, mathematically, to study any theoretical physics subject regarding quantum mechanics, QFT, quantum field theory, general relativity, string theory, or non-commutative geometry, the knowledge of mathematics is a very important. So, firstly, you must know what is the dot product. That is important. I know the mostly students don't know what is the dot product. Mostly students that explain that dot product is A magnitude of A, that magnitude of B cos theta. And some students say that the dot product is multiplication of two vectors which result is a scalar quantity. But all students are wrong because vectors can never be multiplied. वेक्टर को कभी मल्टीप्लाई नहीं किया जाता, तो डॉट प्रोडक्ट इज नॉट मल्टीप्लिकेशन. यस, यू नो इट. आप पहले पता था आपको उस बात का. मिसाल के फॉर एग्जांपल, इफ यू हैव अ वेक्टर ए, it has a component a1, a2, a3. If that has a n dimension, that will be have a n component. Okay. So what is the first postulate of quantum mechanics? As I have already explained to you that quantum mechanically, classically, the particle may be a wave, particle may be a the quantum at quantum level. Classically, all physical quantity are observable. But in quantum mechanics, we can't distinguish that is wave or a particle. So first postulate is about that as we know that some experiment shows that at quantum states things look like a particle and sometimes it look like some experiment shows that are a wave. It is true for a light as well as electrons or other particles. Or all the matters which have length. I should not define it as a wave, but as at quantum state, that will be a very if that is the less than Planck's length, then we can't distinguish that as a wave or they are a particle. So first postulate is at quantum level is that when dimension is less than Planck's length, we can never distinguish that are particle or wave. Okay. Now problem is that according to wave, they have according to the particle, if they are a particle, they must have a mass and they must transfer the momentum. But if they are a wave, then we will consider that they have no mass and there will be no collision or no interaction. Okay, so saying that they have a superposition principle of wave, superposition state of the wave and momentum, mean they have a property of wave as well as the momentum. It is not possible. Okay, so before studying the quantum state, okay, so quantum state is actually the superposition. So we may say that the quantum state is actually the superposition of wave as well as particle state. No question is that how it is possible. Actually, to contrast things is not possible. But there exists a number. Actually, it is not. Fortunately, no one is accepting this concept that they may be a wave or a particle. So, if I say that particle is, so if the quantum state is defined as psi is equal to psi m cos omega t plus phi. Okay, that is what is that? That is classical wave behavior. Yes, we represent the classical wave in such a way. Okay, that is the classical wave. Okay. I think okay. So complex number is complex number is representing by the complex number is representing A plus iota B. Okay. Here A and B are both are real numbers. These are the real numbers. Okay. But even they are a real number, they can be written in this way: A and B. First will be a real and as an order pair. I think in linear algebra you know that what is the meaning of order pair. Okay. So this is the first element and this will be a second element. Okay. And first is representing the real part and second part will be representing the imaginary part. And if we draw the picture, there is angle between 90. This is a complex number. Okay. If we multiply with the iota, if we multiply this number with the, if I say that this is a C, and if I multiply with the iota, even then this become a iota multiply by iota minus B, I may write in this way, and this will become minus B plus iota A. Okay. If I say that this is a new number, let this is a C2. This is a new complex number. If I multiply a C with, then this will be a shape. Okay. If I say that this is a negative number is a new number, I say that this is a D, then I may write it DA. Here D will be a real, A will be a imaginary number. So if we multiply with the complex number, then result will be a change. Real will become complex and complex become real. Okay, and now the angle between now this will be rotate. Okay, so this will be transformed into, if I multiply with the if this is a C and I multiply with the IC. Okay, then this will be rotate, and then that will become a 90 angle. Okay, and now this is I may say that this is iota A and this is minus B. Okay, so this will be a change. So this will be rotate. Okay, and okay, and this will be equal to A minus B, or this will be equal to DA. So the complex number has a property that they may be replace the position. They may be if this is a real, this is along the imaginary. If I multiply, this is another complex number. So these the complex number are if I say that this both A B are real, but we can't distinguish what if that is the second at B, then B may be a if I multiply with these, this will be also defined as a complex number. So it is not necessary that A will always come as a imaginary number or a B as always come. It depends upon what is the complex number. Okay, so it has a two part. So it can be rotate in with each other. Okay, so they can be replace the position. When if we multiply it again, then it also obey the superposition principle, and it also obey superposition principle. Mean if you add a two complex number, the result will be it will have a closure property. In other sense, you know that it has a closure property. What is the closure property? Mean if you add a two complex number, then result will be also a complex number. For example, if you have A and B plus C and D, then real part will be add with the real part, and imaginary part will be add with the imaginary part, and so that will be A plus C and B plus D. Okay, got it? And this will be nazar aa raha hai niche tak? And this will be let's suppose this is alpha and beta. So this will be also a complex number. So in this way, I will not go in a detail. So in this way, we can prove that this complex number, the complex number make a abelian group under addition. Mean they have they obey the closure property. Number one, closure property. Okay, associative property, and additive identity exists, additive inverse exists. Okay, so complex numbers obey the closure property. As I have already explained, number two have obey associative property. Third, what is the third? No, additive identity. The additive will come first. Additive identity. It obey the. It have a minus a minus c, that is element of C, as additive identity. Fourth, it has no, sorry, that is wrong. 0 and 0, sorry. So 0 is 0 will be treated as an additive identity, and minus a and minus b, the element of C, as additive inverse of A and B, element of C2. So for corresponding each element of complex number, they will have a additive identity. And the fifth commutative property, that is C1 plus C2 will be equal to C2 plus C1 hold. Okay, so so it's make a abelian group under addition. So it makes a abelian group under addition. Okay, so there is no. Similarly, other properties like scalar multiplication mean second. This is the capital first that make a abelian mean commutative group under addition. Means all. Okay, so that make a abelian group under addition. Okay, and similarly, if you multiply, if K is any field element, a scalar number, and you multiply C1 plus C2, this K will be multiplied with the C1 and KC2. Third, okay, if we are adding the field number K1 plus K2, and that C is multiplying, then that will be a K1 C plus K2 C. Fourth is K1 K2 K3 with C, K1 K2 K3 C, or K1 K2 K3 C. Fifth was 1 multiplied by C will be a C. Okay. So it obeys all the. So what is the meaning of this? Because it holds all the properties of vector space. Okay. As it holds all the properties, complex number obey the properties of the vector space. It means, what is meaning of this? This is making a vector space over addition. Space over addition. So 1 multiplied by C is equal to C. Okay. Okay. So this make a complex numbers as all differential operators. Differentiable function must make a complex vector space. So come to again, as dual nature. Okay. As if the matter, if we are representing any state, that all state that must be as all differentiable function must make all well-behaved, sorry, all well-behaved differentiable function must make vector space the quantum, and this is a complex number make a vector space as all differentiable functions, all vectors must make a vector space. Okay, and we know that all states must be obey the all solution of differential equations must obey the properties of the vector space, and it obeys. Okay, so it will be hold all the properties of vector space. So any state, if that is regarding because it is combining the two states which are not because complex number is having two states or a composition of two such space which are orthogonal to each other, means they have an orthogonal. Actually, I don't know I think I have to explain firstly what is the dot product. Do you know what is the dot product? क्या होता है? No, dot product is not a multiplication. Yes, you get the result as a scalar, but actually that is not multiplication. And vector can never be multiplied. As you know that there are 10 properties of vectors, and all the properties of the vector is associated with the addition. If you are saying that here is some multiplication is occurred, but this is if that are C1 and C2 are making a vector, then K is a field element that is treating as a number, and so this is the multiplication of a number, that is the not multiplication of vector with the vector. There is no property of vector that vector may be multiplied with the vector. You must remember it. Okay, but I will explain it later. Firstly, so actually, what is the meaning of the dot product? Dot product represent that is not multiplication. Dot product actually represents the effect of one vector on another. If you are what is the meaning? I will explain it later. Actually, dot mean if you are if I am affecting on you, then my dot product will be not zero. But if I am not affecting on you, then my dot product with you is not zero. Now, if I am affecting, then that will be not zero. If I am not affecting on you, then it will be a zero. Okay. So dot product is actually representing the projection or effect or along such kind of form. Okay. I will explain. So in complex number, if the two things have have no relationship, then it means they may be represented in two orthogonal numbers. Means A and B, actually A and B are two such kind of numbers which have no relation with each other. Because whenever you take the dot product, their dot product will be a the dot, if there is angle 90, mean if A and B, if this A is real and it is imaginary part, if we take dot product between the real and imaginary part, that will be a zero. Mean there will be a no effect. Similarly, as we say that the real number properties and wave properties and complex number properties are orthogonal to each other. They have no relation with each other. Wave means no mass, no intersection. Okay, interaction. And particle means having mass and they will momentum. Okay, so so as complex is combination of two orthogonal things which have no relationship with each other. Their dot product is zero. Means here the dot product between, if I represent with the A and B, their dot product with dot product AB. Dot product representing phi D, I will explain it. I don't know you are familiar with this terminology or not. Cat-Broad notation. Are you familiar? Okay. Means here is the dot product between A and B, so that will be a 0. Similarly, a dual state or quantum state, not a dual state, the quantum state is also make a vector space that must be representing the that will be combination of two states, that will be the wave and particle. I mean that will be have such two things which dot product will be a 0. Okay, or if it is not necessary, as I have if we multiply with the imaginary number, it is not necessary what is the first element, real wave is a real or a particle. So this will be a wave, and it may be as a complex number AP, as a C equal to A and B, complex number. Okay, got it? I think it may be a so the complex number and they have a relationship. So the quantum state is actually the complex number state, as it has both are make a vector space, both have a dimension 2, mean two independent dimension, mean two independent variables. There are two independent in complex number, or A and B are independent because their dot product is 0. And wave and particle with wave and particle nature is also a independent. They are a 0. I mean their dot product is 0. Okay. Since both dot product is 0, though both have the same dimension, both make a vector space, both obey all the properties. So this quantum state is representing the wave by a complex number. It must be representing by the complex number. So quantum state is actually the superposition state of as the two orthogonal state. Okay, so we may say that the quantum state is the combination of particle and wave, that you may write that classically we representing that if this is a wave cos omega t plus phi, this is a wave. Okay, if this is because it is a wave, then the other must be a imaginary number. Okay, and there must be a psi m cos omega t plus phi, plus that must be angle 90, because to ensure that they are independent. Okay, got it? So if we take a common psi m, I may take this psi m common, then that will be a cos omega t plus phi. Okay, but what is this? Yes? Yes, I know. But there is this will be a minus iota sine omega t plus phi. It may write in this way. No. Okay. Why this is minus? I must explain it. Yes. We know that sine theta. What is the wave? This is a wave of sine theta. Okay. If I take a cos theta, then Okay, mean here sine 0 is at 0 is 0. Here this is 90. Yani mean they are. Sorry, that's not. I must be careful about that. When it is 90, cos will be at 90 will be 0. It will be maximum. Okay. Here it is again 0. Okay. Okay. Mean this is a sine theta plus 90. Actually, I want to say that. Mean when sine, if I draw, this will become a, if I start from minus sign, then it will be like a sine wave. Okay, got it? Mean when this is a 0, this will be a 90. When this is a 90, it will be a 0. When it is again 0, then it will be a minus 90 because it, and then when it is a 90, then it will be a 0. So it means that will be also like a sine wave, circular wave. But it you may say that if it is looking difficult to understand, you may understand that the sine wave is like that. This is starting from here, and this is moving in this way. But cos wave is starting from angle 90. Okay, this is starting from the 90, and then mean it will be start from 0. It will be start from 90. Okay, so that is the difference between the sine wave and cos wave. Got it? So there is a difference of the 90. So that's why it will. Okay. So sine theta plus pi by 2 is cos theta. Okay. And that will be a minus sine theta. At pi, that will be parity will be reversed. Okay, got it? So so that's why the cos theta will be a minus sine theta. Okay, so this sine omega t, that will be as mean sine. In short, I think it. Maybe I am making it difficult. That means cos theta. So this formula I have used. Theta plus pi by 2. So if I add the angle, if we add the angle 90, then that will be cos theta by. So that's I have used here. Okay. Have you any questions? Okay. So that's clear. Okay. So this and as I think in complex number, you know that this is, what is this? Exponential of. If I say this is angle alpha and both are angle same theta, this will be exponential of minus alpha, mean this will be or this. Okay. Oh, sorry. here will be iota. Actually, E iota alpha is cos alpha plus iota sin alpha. I think this is trigonometric relation. You will be familiar with this. And minus iota theta is equal to, this will be equal to cos minus alpha plus sin minus alpha. Yes? Cos is even number, is an even function. This will be a cos alpha plus, sorry, minus iota sin alpha. That's the relation I have used here. Okay. So this is the quantum state. The quantum state is so this quantum state. I say that this is actually I may write in this way too, that E is equal to minus iota omega t plus 1. And after then we will prove that that is Kx. Okay. Okay. Got it. So I think you know that this is the quantum state. Okay. Okay. So what is the quantum state? Quantum state mean quantum state mean the combination of two states which can never be exist simultaneously in common sense. In common sense language, they may never exist together, okay, simultaneously. But in quantum numbers, as real and imaginary part combine in a quantum number, the quantum state means the combination of two existence of two such states which can never be exist, that must not exist in a common sense. Okay, so that represents the existence of the particle behavior and wave behavior. If we can't distinguish this in this state, we can't distinguish that that is wave or a particle. They have a mass, they have not mass. Okay, so that means the quantum state is actually the psi is psi m exponential of minus iota kx plus phi, and we have proved that. Okay, the quantum state may be representing by this. This state, quantum state, has all information about. It has it has all information about state, but we can't extract. That information can't be extracted. Means they have a information, but we can't extract. But we can only find the probability. Okay? But we may only find the probability. We may find only the probabilities, because this is the quantum state is a complex state, and that's why we, in complex state means we can't extract information, but we can only find the probability. Or we may find the probability. Probability may be measured by the dot product. What is that? We will explain later. Okay, that is phi. Okay, and that is exponential of iota minus sorry, What is that? This is okay. Taking Hermitian conjugate and this. Okay. The sign will be changed. Okay. E की power 0 is 1. Okay. Sorry, 10 e की power 0. So this will be a psi m, and psi m exponential 0 is 1, that is equal to 1. So that will be a psi m. This is actually, this I will explain it later. This will be this. That will be the probability. Okay, the maximum amplitude. Got it? Anything else? So this is the probability. What is this? This is defined as Hermitian conjugate of psi, and this is actually the two operation that is defined as complex conjugate and transpose. Okay, so that and this will be equal to this bra. Hermitian conjugate of the cat is defined as a bra. Okay. So now we will explain what is this.